In this video, we're going to take a look at the product and quotient rule for derivatives. So the product rule is when you're taking the derivative of two functions, we'll say f of x and g of x being multiplied, and we'll figure out what that is in a minute. The quotient rule is when we take the derivative and we see one function being divided by another function. And again, we'll see what that is in a minute. So the product rule, again, we're looking for two things being multiplied together. Now, typically, people will see this rule that if you ddx and they'll use f times g, okay, or sometimes some books will use u and g, you'll see this as f prime g plus g prime f. Some people get confused with that. It's pretty straightforward. I like the idea of using underlines, my first function and my second function. So I take the derivative of the first, multiply it by the second. I take my derivative of the second, multiply it by the first. And if we use the underline method, we're less likely to leave things out. Now, there is another little hack I like to look at. See, I'll write those two functions down. So we'll have our first one, and then we'll have our second one. And then underneath that, I'll write down the derivative. So the derivative of the first one and the derivative of the second one. And what I tell people to do is just go ahead and multiply across like that. So you will have the derivative of the first times the second. And then we're going to multiply across here, and we're going to say plus, and we're going to have the derivative of the second, and that's going to be times the first. And again, we could do that with underlines, first, second, second, first. So we can set up a little chart like that. So we'll take a look at how I use this in the following examples. Quotient rule, again, we're recognizing that there's a function on the numerator and a function in the denominator, and again, when you see that, typically it's written as ddx of, let's say, f over g. You're going to see this as f prime, the derivative of the numerator, times g. Now it's going to be minus the derivative of the denominator times f, our numerator, all over g squared. And again, people remember this different ways. Some people say d top times bottom minus d bottom times top. And so whatever works for you. Again, I'm going to show you my little hack for this. I look at the top and the bottom, much the way I did in the last problem for the product rule. So we have those written down. And then underneath that, I'm going to write their derivatives, whatever they may be. And I'm going to do pretty much the same idea where we're going to multiply across. So we're going to have the derivative of the top function, or the first function, times the bottom. But now, since it's the quotient rule, when I think of division, to me that relates to subtraction. So now we have minus. Then here we're going to have the derivative of the bottom times that top function. And then we do have to just remember that all of this is always over the bottom function squared. All right, so let's take a look at some examples and we'll see how to use this. So in all these examples, we're going to be finding the first derivative. Let's take a look. So I notice right away x squared is my first function and sine x is distinctly my second function. So again, I can just go ahead and do fill in the blanks here, derivative of the first times the second plus the derivative of the second times the first, and we can write that out. So we can identify the idea of x squared as one function and the sine of x as the other. Our derivatives would be 2x, and the derivative of sine x is cosine x. So we have all our answers up here. We just have to fill in the blanks. So to help us out, let's go ahead and do this little cross-multiplying trick. We have 2x times sine x, so we'd have 2x sine x. And then over here, we have cosine x times x squared. And again, because it's multiplication, the order doesn't matter, so we can rewrite this however we want. So let's just clean this up. So you have 2x sine x plus, and again, I like to put the polynomial first, x squared cosine x. And we could put this in descending order, however we want to rewrite it, but there it is. Product rule. So again, same idea, product rule, pretty easy to recognize there are two distinct functions. Here's our first, multiplying our second. Again, we can do the idea of fill in the blanks, or let's just go ahead and do this idea. X cubed, that derivative is 3x squared using the power rule. And then we have f of x, and the derivative of that is f prime of x. And again, let's go back and kind of just do our little cross multiply trick. So we're going to have 3x squared times f of x. plus, and then over here, we're going to have x cubed times f prime of x. And that is what y prime is going to equal. Now, it is okay we don't know what f prime of x is because we don't know what f of x is, some general function, or maybe we'll be given point values later on that we can substitute in and solve for. Number 3 looks a little more complicated, but again, it just does it in pieces. So what I need to recognize first up is that I have two functions here being multiplied, first and second. Then there's another problem over here, first and second. So we're going to do the product rule on two different sets here. And then we also have to realize that 1 over x isn't written in the form we prefer. We do prefer x to the negative 1, or maybe this is a derivative we've memorized. So let's go ahead and take a look. We'll do this separately and we'll piece them together. So we have x to the negative 1 and we have g of x. We have those derivatives. So this derivative is negative 1x to the negative 2, which is also known as negative 1 over x squared. And here we have g prime of x. Our other values over here, we have x squared and we have sine of x. Those derivatives, looks familiar, 2x and cos x. So let's go ahead and do our cross multiplying. And when we do that, we're going to have g of x times negative 1 over x squared. You know, how are we going to write this? We can write negative g of x over x squared right away if we like. And then we're going to multiply these two across. So x to the negative 1 is 1 over x. So we're going to say plus, and times g prime of x, we'll have g prime of x over x. And then remember, over here we had minus, so we're subtracting, and this is where we have to be careful. We're subtracting this whole thing. So when we do that, and we go across here, it's inside, so we're going to have 2x sine x plus, or we can distribute that negative, and then we're going to have x squared times cosine of x. So let's clean that up over to the side here, see if I can rewrite that a little nicer for you. So we're going to have negative g of x over x squared, plus we have g prime of x over x. And again, this could be written in different forms. Now let's go ahead and distribute that negative. This is the most common mistake with the product rule, is distributing a negative over it. And you'll see it later on with implicit differentiation. 2x sine x. And distributing that negative, there it is at minus x squared cosine x. So if we had to rewrite it in different ways, this is one way you may see it if it's a little more simplified. Number 4, again, we have a slight problem here. We have x squared minus 4x. That is our distinct function, this whole thing. And then we have sine x as our second function. And then we just have a simple root x sitting out there. No product rule needed. We can do that one straight up. Now we have an option here. We can distribute x squared minus 4x to the sine of x, or sine of x to those, or we can do it as is. It doesn't make a difference. Let's just go ahead and try it this way, as identifying this as our first function and that as our second. So we have x squared minus 4x as our first function. Our second function is sine of x, so our derivative, 2x minus 4, derivative of sine x is cosine x. So again, a little cross multiply trick, but when we do that, realize you have 2x minus 4. The whole thing is being multiplied by sine x, plus, and again, x squared minus 4x, that whole thing, that's that whole first function, times cosine of x. And then we do need to go ahead and take the derivative of root x, and some of you may rewrite that as x to the 1/2, or some of you may have it memorized as simply 1 over 2 root x. I recommend that. So we can just add that on to the end there, plus 1 over 2 root x. And this is your y prime. This is your derivative. And again, it can be written different ways. It could be distributed or simplified, but we're going to go ahead and leave it like this. All right, number 5. So we're recognizing this is not the product rule because we have division. Now, some of you are thinking, wow, I could rewrite that as a multiplication problem because down here we have x to the first. This can be rewritten as x to the negative 1 times sine of x. So you could use the product rule, but we're going to use this opportunity for the quotient rule. So here we have our top function, and then here we have our bottom, we can call it numerator, denominator, however you'd like to look at it. So let's go ahead and do that. So we're going to need derivatives, so let's go ahead and write down sine of x. And then the bottom function is simply x. It's not x to the negative 1. We're looking at this by itself. That's one function. and that is our other function. Now we're going to look at the derivatives. So we have cosine of x and we have 1. It's kind of nice. And then, so for quotient rule, when we multiply, we're going to have x cosine of x. So now instead of plus, it's minus sine of x times 1. I'll write down the obvious, 1 over sine of x, 1 times sine of x. And all of this is over that bottom squared, so it's over x squared. So let's go ahead and rewrite this. We're left with y prime equals x cosine of x minus, now we'll just say sine of x all over x squared. And that is all there is to it. And using the product rule would have led to the same thing. You would have had two functions separated, and if you had to add them with a common denominator, this is what would have happened. Number 6, again, we have our top and our bottom. So let's just go ahead and write that down here. You know, our top function is x squared plus x. Our bottom function is 2x minus 1. Now we're going to look at the derivatives right underneath. So we have 2x plus 1, and we have just 2. So we can go ahead and use our little cross multiply trick. So we're going to have 2x plus 1 times 2x minus 1. And then remember, we subtract, and we're going to have 2 times x squared plus x. And then all of this, we'll just put it right here, all of this is going to be over the bottom squared, so we're going to have 2x minus 1 squared. Now, typically in the quotient rule, things happen when you simplify. So we are going to go ahead and simplify this, so we're going to have to do a little bit of algebra work here. We're going to go a little fast. Some of you may recognize this as conjugate pairs, so simplifying that gives you 4x squared minus 1. And then remember, we're distributing a negative 2 here, so then we have minus 2x squared minus 2x. And all of that is over 2x minus 1 quantity squared. And we can simplify a little bit more up there. You'll notice we have the 4x squared minus 2x squared, so we're going to have 2x squared. Put this in order, minus 2x minus 1 all over 2x minus 1, that quantity squared. And we've simplified that a little bit more. Sometimes things will factor out and you'll be able to cancel and simplify more, but in this case, we are good. Number 7, again, this is more of a general form, but same idea. We're recognizing we can use the quotient rule here. We have our top function, which is this whole thing, and our bottom function, which is this whole thing. And we'll just go ahead and write those down. So I have x squared times f of x. So it looks like we're going to have a little work for ourselves there with the product rule. And then we're going to have g of x plus 1. So underneath, we're going to write our derivatives, but realize I need my little product rule. And if we've used that enough, maybe we know it. So let's just try this out loud. We're going to have 2x times f of x plus f prime of x times x squared. Okay, not too bad. And then the derivative of the g of x plus 1, well, the 1 goes to 0 when you take derivative, and derivative of g of x is just g prime of x. So could be a little sloppy. We're going to go ahead and cross multiply. So, you know, this one's going to go that way, this one's going to go that way. So down here, we're going to have the whole thing, g of x plus 1, put that in parentheses, times this whole derivative down here, which was 2x f of x plus, and I'll rewrite this so the x squared is first, x squared f prime of x. And then we're going to have, remember it's minus, and these two being multiplied, you know, going across here to give myself enough room. We're going to have g prime of x times that, so we're going to have x squared times f of x times g prime of x. And don't forget, all of this is over the bottom squared, so this is all over g of x plus 1, that quantity squared. And we could go ahead and try to simplify this, but usually in a problem like this, you're told to evaluate it. Let's say x equals 2, and you're given some other values. So I would actually just leave it like this for now and just plug in the answers if we had more values. Number 8 looks a little complicated, so let's clean this up when you can. So when I have a fraction inside a fraction, we call that a complex fraction. So what we like to do is clear the fraction. So since our denominator is x, I multiply the numerator by x and this denominator by x, and we'll get something that looks like this. That will cancel out, leaving us with 1 plus x cubed over and x squared minus 3x. Much easier to work with, especially using the quotient rule. So again, our top function, 1 plus x cubed. Our bottom function, x squared minus 3x. Let's take those derivatives, and we have 3x squared. Here we have 2x minus 3, and we'll go ahead and use our little cross multiply trick. So we have 3x squared, the derivative of the top, times the bottom, which is x squared minus 3x, minus, and then again, we're going to have the derivative of the bottom, which is 2x minus 3, times the top, which is 1 plus x cubed, all over our bottom function squared, which remember, we rewrote it to here, so we have x squared minus 3x, that quantity squared. Now again, this should be cleaned up, so let's go ahead and do the algebra for this one. So we're going to go ahead and distribute that 3x squared. So we have 3x to the fourth minus, now we'll have 9x cubed. And then remember, we're subtracting this whole thing, so I'm going to keep a bracket here while we FOIL this out or distribute it. So we'd have 2x, and then we're going to have plus 2x to the fourth, distributing the 2x, minus 3 minus 3x cubed. Again, we're going to be looking for like terms. So before I put it over the bottom squared, let's just go ahead and clean this up a little bit. 3x to the fourth minus 9x cubed minus 2x to the fourth. Remember, we're distributing this negative, plus 3 plus 3x cubed. Let's go ahead and look for like terms now. So we have fourths being the highest. We have 3x to the fourth minus 2x to the fourth, x to the fourth, minus 9x cubed plus 3x cubed minus 6x cubed. Then we have just minus 2x and plus 3. But again, all of that is over the bottom squared, which we can see up there is x squared minus 3x, that quantity squared. So I hope that helps you make using the product rule and quotient rule a little bit easier.